everyone, and welcome to lesson 7.5. In today's lesson, we're going to talk about parts of similar triangles. So again, we already know that the triangles are similar, and now we're talking about what happens when you have special pieces. The nice thing is we already know what these pieces are. And here they are. So these are the three types of special pieces, and when you have triangles that you know are similar, then these special pieces are also corresponding or proportionate to corresponding sides. So this first one up is altitudes. Hopefully we know what altitudes are. They are perpendicular. They come from a vertex and are perpendicular to the opposite side. Okay, these are also known as heights. I don't think I spelled that right. There, I fixed it. So when you have altitudes within similar triangles, what this means is that the ratio of the altitudes is proportionate to the ratio of corresponding sides. Now we could pick any. I'm going to go with these two sides for no other reason than they're right there. And there you have it. So altitudes are proportionate to corresponding sides in similar triangles. Now this next one up is, hopefully you can tell by the picture, angle bisectors. Okay. As a reminder, angle bisectors, they are cutting the angle in half. And when you have an angle bisector, then the bisector itself is proportionate to corresponding sides. So in this case, we're going to have QS over UW is equal to, proportionate to, I'm going to pick these two corresponding sides, QR over UV. Angle bisector, proportionate to corresponding sides. Last but not least, this one down here is a median. Now hopefully you're remembering this, or you can just see by the picture, but the median is going to intersect the midpoint of the opposite side. So it has to come from a vertex. So it has to come from a vertex and go to the midpoint. Just like an altitude has to go from a vertex to the opposite side. And just like all the others, if you have this in a similar triangle, then the altitudes, or then the medians themselves, so HJ over LN, let's go with this one, is proportionate to HI over LN. And you could have used any of the corresponding pieces or the corresponding sides. I just picked the one I did at random. Now let's see what happens when we have problems. So in this first one, we have medians. Okay, if you're looking at it, you can see it goes from the vertex and bisects the opposite side. So we have medians. Therefore, the ratio of my medians is going to be proportionate to the ratio of a side. So that's going to be x over 15 is proportionate to. Now we can kind of pick our favorite here. I'm going to avoid SU because it has a decimal, and you guys know how I feel about decimals. I'm going to pick ST. Okay, so 16. Now the triangles are not in corresponding positions, so I'm going to use my statement to figure out that DE corresponds to ST. So there we go. So 16 over 20. Now you can cross multiply like this. I want smaller numbers. So I'm going to go x over 15 is equal to 4 over 5. And all I did, I'm going to change colors, all I did is just divide by 4. So 16 divided by 4 is 4. 20 divided by 4 is 5. And this just gives me smaller numbers and nicer numbers and just makes math easier, which I think we all want in life. All right, so once you're here, you're going to cross multiply. And that is going to give you 60 is equal to 5x, which, when you divide by 5, is 12. And there you go. All right, now the next one, you have altitudes. And you can tell because you go from an angle and you have a right angle. The video is going to pause. Try setting this one up and seeing how far you get. When it plays again, the setup will be there, and then we'll solve together. Okay, so here's the setup. We have 10 over 8 is equal to x over 14. If you have this rearranged as an 8 over 10 equals 14 over x, it's not going to affect your math, but it does go against the statement. And since we have a similarity statement, we're going to order our problem by the similarity statement, just so we don't have, or just so that everything stays organized. All right, so now I'm going to simplify, divide by 2 to both sides, and I get 5 over 4, 5 over 4 is equal to x over 14. And then we cross multiply and solve like always. So 5 times 14 is 70. 4x. I don't think that when we divide both sides by 4, it's going to go evenly. So I'm going to divide by 2, or simplify my fraction. So I do have, let's back up. I do have 70 over 4 equals x. Now I'm going to simplify by 2. And that does give me 35 over 2 as my fraction. And guys, just leave it alone, okay? It's a fraction. It's fine. Fractions are superior anyway. Let's move on to another problem. So in this problem, we have medians again. Not a big problem. All we're doing is recognizing which pieces we have. This one is a median. Okay? So what I want you to do, try to set up your proportion. When the video plays, you'll have a setup. And then if you want, try to keep going as far as you possibly can and see if we get the same answer. So here's the setup. Notice I already went ahead and simplified my fraction to get smaller numbers. And my other fraction has expressions. Not a problem, just make sure you distribute. So when I cross multiply, I have 3 times 2x minus 9 is equal to 5 times x minus 2. Now, if mentally you have already moved on to the next step, totally fine. I am writing that step out so that everyone can clearly see where I'm going. Now that I'm here, I'm just going to keep solving. Subtract 5 from both sides, and you get x minus 27 equals negative 10. Add 27 to both sides, and you get x is equal to 17. Now, make sure you pay attention in the instructions, okay? On these particular problems, I think the instructions got edited out, but you were just solving for x, okay? There's only one variable, solving for x. In future, please make sure you are paying attention to the wording, especially when you have expressions in your problem. Sometimes the problem will ask you to solve for YC or solve for LH, okay? So you solve for x, yes, but then you got to plug back in. Now, last theorem of the day is the triangle angle bisector theorem. So of the last few problems, the one we didn't talk about a whole lot was what happens when you have angle bisectors. Now, if you have an angle bisector into similar triangles, it operates the same way as the medians and the altitudes do. But if you have an angle bisector in a singular triangle, okay, so an angle bisector in a singular triangle, then it separates the pieces into proportionate lengths on either side. So what this means is because I have an angle bisector right here, okay, let's just label these A, B, C, and D. Actually, change my mind. Let's go A, B, X, and Y. Because we have an angle bisector, then the one side of the triangle is proportionate to the other side of the triangle. So A over Y is proportionate to B over X. And then you can cross multiply like normal. This is unique from all of our other problems because all of our other problems required two similar triangles before you could have proportionate sides. So this theorem is unique to angle bisectors, as it says, angle bisector theorem. Okay? This is unique to triangles that have angle bisectors because when you have an angle bisector, the one half is proportionate to the other. So let's go ahead and solve this bottom one. All right, so we have an angle bisector. It's not marked, but I assure you it's there. Ta-da, there it is. This side of the triangle is proportionate to this side of the triangle. So I set this up, and it's going to be 12 over 4.8 is equal to 18 over x. And then we can cross multiply. When we do, we get 12x is equal to 86.4. I'm leaving the decimal in because the problem has a decimal. I still maintain fractions are superior, though. I can feel you all rolling your eyes. It's okay. Which means your final answer is 7.2. Now, here is a small trick. I'm going to change colors so you can see the trick. Because we are not dealing with similar triangles, we're just dealing with proportionate pieces, we can play around with them. Okay, so in this first, the red part, this first setup, all right, I did it the way we explained in the top. Okay, one side proportional to the other side. Now I'm going to rearrange my ratios so that my numbers are a bit nicer to me. What I'm going to do is I'm going to say 12 over 18 is equal to 4.8 over x. So in this example, I did the top of the triangle proportionate to the bottom of the triangle. And the reason why this works is because in order for two things to be proportionate, the cross products need to be equal. Okay, when I multiply, notice how I'm still multiplying 12 times x, I'm still multiplying 18 by 4.8. So far, so good. We're doing the exact same problem. The reason why I like this one better is because with 12 over 18 as my first ratio, I can simplify. I can divide both of those by 6 and get 2 over 3 is proportionate to 4.8 over x, and this just simplifies my life. Now I have 2x is equal to, what's 4.8 times 3? 14.4. And this is just a little simpler of a math problem to do without a calculator. Notice we still get the exact same answer. We get the exact same answer because our cross products were the same. So either way, whichever way you want to go, I will usually pick the way that gives me a fraction I can reduce. Okay? So that's my trick. You can use it if you like, or you can just pick your favorite and move on from there. So here are two other problems. Both of these have angle bisectors. I don't know why it's not there, but it's an angle bisector, so ta-da. Now, the unique thing about these two types of problems is if you look a little closely, one of the pieces that we need is not given to us. It's not that big of a hurdle. Remember that when you have an angle bisector, one side of the triangle is proportionate to the other side of the triangle. Like this. But I do not have this piece right here. So the extra step involved in this problem is you have to do a quick subtraction and, figure it out. So 39 minus 15 is 24. Don't know why it did that. Oh well. Ta-da, and 24. Now I have all my pieces, and now I can set up my fractions. Go ahead, you try, see if we get the same answer. And there you go. So you have the setup, I reduced my numbers, and solved. Leave your answer as a fraction. Okay, the next one has expressions in it, but you do it the exact same way. See if you can set up the problem. When the video plays again, you'll see the setup. So as you can see in the second problem, I went with the bottom part of the triangle as one ratio and the top part of the triangle as my second ratio. And again, the reason why I did that is because 27 and 18 are both divisible by 9, and that just gives me smaller numbers. All right, video's going to pause again. Try to solve it all the way out. When it plays, you'll see the answer. And here's your answer. Always double check for math errors and double check to make sure that you didn't make any sign errors along the way. All right, this is the PowerPoint. Let me know when you have any questions, and I will see you next time.